Now we will take some problems of simply supported with symmetric loading. So for example, here I take a simply supported AB with symmetric loading, that is 50 km at the center. So whenever symmetric loading is there, the maximum deflection occurs at the center. Unsymmetric loading, it will be near the center, not exactly at center. But in case if it is symmetrically loaded, it will be occurring at the center. So you know that for this case, the bending moment diagram, it will be WL by 4 EI. If you calculate W into L by 4 EI, it comes 50 by EI. This is the deflected shape, and this is the point of maximum deflection. And if you draw the tangent at the point of maximum deflection, you know that tangent comes horizontal. Whenever the tangent is horizontal, always the tangent will be horizontal only at the point where the deflection is maximum. And when the tangent is horizontal, its inclination with respect to 0, with respect to horizontal is also 0. That means at the point of maximum deflection, slope is 0. So to calculate the change now, and here has to calculate maximum slope and maximum deflection. Here maximum slope always occurs at either A or B. You calculate theta A or theta B. Then to get maximum slope, that is theta A, what I have to do now? You know that at C, theta C is 0. Now theta A minus theta C is 0, directly you will get here theta A. But whereas in unsymmetrical problems, you will be not knowing initially where the maximum point of deflection is there. So that's why if you take area between any 2 points, you will not get the theta A or theta C like that. But if you know the point of maximum deflection, and if you take the area of M by EI diagram between the point of deflection and another any point, it gives you directly slope at that point. Now actually you look at change in slope between C and A, that is this is nothing but theta AC. Theta AC is nothing but theta A minus theta C. But you know that at the point of maximum deflection, that is C, theta C is, you know that it will be 0. So if this is 0, what happens? You will get theta A. What is theta AC? The change in the area of M by EI, change in slope between A and C, that is given by area of M by diagram between C and A. So this is the area of M by EI diagram between C and A. It is half, base is 2, height is 50 by EI. So if you simplify this, you are going to get here 50 by EI. This is the maximum slope or slope at A. Then how to get the maximum deflection? Again, you know that maximum deflection occurs here. So general way of calculating deflection is this C double dash minus C dash C double dash. But it is very simple to calculate when it is the point of maximum deflection is known. Here this is the point of maximum deflection. So this is horizontal. Then this is Y maximum in fact. So this Y maximum is equal to, you know that it is TAC. What is TAC? Tangential deviation of A with respect to tangent drawn from C. How to calculate TAC? It is the area of M by EI diagram between A and C, and you have to multiply the distance of CZ with respect to A, because you are calculating the distance tangential deviation of A. Now when you take the area between A and C, what is that? Half, base is 2, height is 50 by EI. This is the area between A and C. Distance of CZ from A is 2/3 of base. That is, what is base? 2, 2/3 of 2. If you simplify this, you are going to get here 66.67 divided by EI is the value of maximum deflection.
Done.
So we will consider one more problem of symmetric loading AB of span 8 meter. Say it is carrying UDL over the entire span. The intensity is 10 km per meter. It is symmetrically loaded. So you know that this is the bending moment diagram. It is WL square by 8EI. If you calculate this, 80 by EI it comes. This is the deflected shape or elastic curve. So you know that again it is symmetric loading, hence the maximum deflection occurs at the center. C dash will be your Y maximum. And you know that at the point of maximum deflection, slope will be 0. So if you take the area of M by EI divided by A and C, it gives you theta A minus theta C, but theta C is 0, directly we will get theta A. That is, change in slope between C and A is nothing but the area of M by EI diagram between C and A. So theta AC is nothing but theta A minus theta C, but you know that theta C is 0. Hence, theta AC is given by change in area of M by EI diagram between C and A, that is equals to theta A. What is the area of M by EI diagram between C and A? Now this is the area of M by EI diagram between C and A. So in cantilevers, you know that if you take the bending moment diagram, this is 1/3 of the base into height. Now for this case, if this is like this, it will be 2/3 of the rectangle covered by that curve. So 2/3 of base is 4 because it is center. So this is 4 meter, 2/3 of 4 into height. So this will give 213.33 by year. Then to calculate the maximum deflection which is occurring at the center, you know that y maximum, actually you have to calculate, if you want to calculate this way, this minus this you can calculate, TBA you have to calculate, that all things. But in case of symmetric loading, or if you know the point of maximum deflection, directly that y maximum can be calculated by the geometry of the figure, because this y maximum is equals to, it is same as the vertical distance between point A and the tangent drawn from C. That is nothing but a tangential deviation of A with respect to C. How to get the tangential deviation of A with respect to C? You have to take the area of M by A diagram between A and C, and you have to multiply by the distance of CG of that figure with respect to A, because you are calculating with respect to A. You know area of M by A diagram already calculated, that is 213.33 by I. Now I keep it here, 213.33 Vi into x bar with respect to A. So you know that here from this it will be 5/8 of base. Here it is 3/4 of base and 1/4 of base. But in this case, this distance is 5/8 of base and this will be 3/8 of base. Now 0 and it is 5/8 of base. So 5/8 of 4. If you simplify this, you will get here 533.325 by ear. So only tangential deviation when it becomes a deflection means at this time is only in case if C is the point of maximum deflection. If it is not point of maximum deflection, then you have to calculate that TBA first you have to calculate, then you have to calculate this C double dash like this, then C dash, C double dash you have to calculate, then this minus this gives you that Y maximum. But this is the advantage of simply supported beam with symmetric loading. Whenever symmetric loading is there, maximum deflection occurs at the center. So taking there the slope as 0, you can calculate the slope at any point. Similarly, maximum deflection can be taken as the tangential deviation of that A with respect to that point tangent drawn from C. So you have to take the area of M by E diagonal A and C about A. That gives you directly YCR, Y maximum.